Hello everyone, I hope you are doing well. And in this session, I am going to explain some geometrical concepts. Let's get started. First of all, I want to differentiate between the median of a triangle and the angle bisector, as you see here. What is the difference between the median and angle bisector? The median of a triangle is the line segment drawn from any vertex divides the base into two equal sides. But the angle bisector is the ray drawn from the vertex of any triangle and divide the angle into two equal angles, dividing the angle into two equal angles. So the angle bisector here, this is angle bisector. As you see, AD is an angle bisector. And the angle bisector bisects the vertex angle into two equal angles. So the size of angle A, or angle 1, is equal to the size of angle 2. But the median of a triangle is the line segment drawn from any vertex and divides the base into two equal parts. So if AD is a median, then the length of BD is equal to the length of DC. If we have a triangle, like this triangle, as you see, the triangle is A, B, C. And there is an angle bisector drawn from the vertex A. So I'm going to draw an angle bisector. This is angle bisector. So the size of this angle, is equal to the size of this angle. Let's say this is angle 1, and this angle is called angle 2. So if AD is angle bisector, AB is angle bisector. So the size of angle 1, that means the size of angle 1 is equal to the size of angle 2. I want to prove that AB over AC equals BD over DC. Let's draw a construction. Let's draw a side parallel to AD, as you see here. So I have drawn BE parallel to AD. If we looked at the two parallel sides, you'll find that you have two alternate angles. The size of this angle, 3, is equal to the size of angle 1. Why? Because they are two alternate angles. So angle 1, the size of angle 1 equal the size of angle 3, y two alternate angles, And the size of angle 2, let's suppose this angle is 4. The size of angle 2 is equal to the size of angle 4. Why angle 2 is equal to the size of angle 4? The size of angle 2 is equal to the size of angle 4. As you see, they are taking the form of letter F in English. Angle 4, angle 2. And angle 1 and angle 3, the angle 1 and the angle 3, they are taking the form of angle Z in English. So they are equal. Angle 1 is equal to angle 3. And because AD is a bisector and angle 1 is equal to angle 2. And at the moment, angle 1 is equal to angle 3 and angle 2 is equal to angle 4. So we can say that the size of angle 1 is equal to the size of angle 2 is equal to the size of angle 3 is equal to the size of angle 4. So all of them are equal. So we can say that we can deduce that angle 3 equals angle 4. And from that, because we have two equal angles in this triangle, we have two equal angles in this triangle. Angle 4 is equal to angle 3. So we have two equal sides. The side AE is equal to the side of AB. AE is equal to AB. So the length of this side will be equal to the length of this side. So AE equals AB. Keep it now because we are going to use it after a while. Let's discuss now the proportional parts. We have studied it in the previous lesson. Because AD is parallel to BE, so we can say that CA over AE is equal to CD over DB. Once again, because they are parallel, the two sides here are parallel, this side and this side, they are parallel. This side here is parallel to this side. So CA over AE is equal to CD over DB. Keep it now because we are going to use it after a while. Once again, because they are two parallel, I have two parallel sides in a triangle, so we can apply proportional parts, which CA, this is the first part, over AE, the second part. Just to imagine it well, I will draw a small triangle in this room, and this is CA. They are parallel. CA over AE is equal to CD over DB. And we know that, as you see, AE is equal to AB. So we can take AE and substitute AE is equal to AB. So we can write a conclusion for that. We can write CA over. Instead of AE, we can write AB. So CA over AB equals CD over DB. That's it. I proved that. Then if we looked at the proof, we will find that I have proved CA over AB is equal to CD over DB. Let's look at the triangle. This is CA, this side, I mean this side. I'm going to color it in green. CA, this side. And this is a side from the three sides of the triangle. Over AB, another side. So this is a side. Is equal to CD. This is the base, as you see, over DB. So we reach to a conclusion, which is the angle bisector. The angle bisector. This is the angle bisector. From any vertex, this is the vertex I mean, divides the base into two parts. Divides the base into two parts. The two parts are equal to the ratio between the other two sides. So in a simple words, we can say that if we are going to take the ratio, if we are going to find the ratio between AC and AB, you will find that this ratio is equal to the ratio between the two parts of the base, CD over DB. That's it. So if we have a triangle, once again, if we have a triangle, like this triangle ABC, and I'm going to draw an angle bisector. The meaning of angle bisector, again, it's the ray which divides any vertex, which divides the vertex into two equal angles. And what is the conclusion? We have got AC, this is a side, over AB. If you are going to find the ratio of AC and AB, so AC over AB is equal to CD over BD. Once again, if you are going to write, or you are going to find the ratio between BD firstly, you are going to start with B. So BD, for example, you started with BD. Okay, over DC, the parts of the base. Let's say it's part 1, and this is part 2. The ratio between BD over DC. You should write, it's a must, you should write AB firstly, because you have taken BD, the part 1. So take side 1. This is side 1, for example. So write AB over side 2, which is AC. If you are going to find the ratio between CD over BD, so you started with this part, CD over BD, this is part 1, and this is part 2, is equal to AC, this is side 2, because you have taken CD firstly, so you should take AC, it's side 2, so write AC over AB. That's it. And if you are going to find the length of angle bisector, AD, how can we find the length of AD? AD will be equal to the square root of AC times AB. AC, side 1 times side 2. Side 1 times side 2 minus part 1 times part 2, which are BD times DC. So how can we find the length of the angle bisector? Just the square root of side 1, square root of side 1 times side 2 minus part 1 times part 2. So what is the conclusion we reached? I've said that the angle bisector from any vertex divided the base into two parts. The ratio between them is equal to the ratio between the other two sides of the triangle. Did you get it? Let's take an example about this part. This one. As you see here, this is a triangle. And I have an angle bisector. This is the angle bisector. This is the angle bisector. I have an angle bisector. And the triangle, as you see, this is triangle A, B, C. So just to focus on the angle bisector, this is the angle bisector, and this is side, let's say it's a side 1, and this side, it's a side 2. And if you know that we have an angle bisector, so the angle bisector divide the two sides in ratio, which is equal to the ratio between the two parts of the base. This is part 1, and this is part 2. So 6 centimeters, which is AB over 8 centimeters, is equal to, I don't know actually the length of BD, and I don't know the length of CD, but I have 10.5, this 10.5. So we can write here X, we can write X and write 10.5 minus X, because all the length of the base is 10.5. So I suppose that BD is equal to X, then CD is equal to 10.5 minus X. So write X over 10.5 minus X and do cross multiplying. X times 8, it's 8X equals 6 times 10.5, it's 63 minus 6X. So 8X plus 6X equals 63. Okay. Then 14X equals 63. Then X equals 63 divided by 14. 63 divided by 14, it's 9, it will be 4.5 centimeters. So the length of BD is equal to 4.5. BD equals 4.5 centimeters. And we can find the length of CD if we subtracted 10.5 minus 4.5 equals 6 centimeters. That's it. Let's take another one. This one, as you see here. I have a triangle, this triangle, and I have an angle bisector. This is the angle bisector. So the angle bisector divide the base into two parts. The ratio between them, this is the base, and they are the two parts. The ratio between them equals the ratio between the other two sides. So if we suppose that this is side 1 and this side is side 2, because this angle, this angle A, this is called the vertex angle, and this is the bisector which divides the angle into two equal angles. So side 1 over side 2 is equal to part 1 over part 2. I want to find dF over FC. We can find dE, this is dE, over EV from this triangle. This side is 6 and this side is 8. So because we have an angle bisector, so 6 over 8, side 1 over side 2 is equal to part 1 over part 2 is equal to dE over EB. So dE over AB equals 6 over 8, simplify it, 3 over 4. So part 1 is 3 and part 2 is 4. The ratio between them, it's not the actual length. They are not the actual length, but its ratio. When we find the ratio between DE and EB, it will be 3 to 4. Let's move to the other triangle. And I have two parallel sides. They are two parallel sides, as you see. So the proportional part is because we have two parallel sides in a triangle. Part 1 over part 2 is equal to dF over FC. They are parallel. Once again, DE over AB. DE over AB. In triangle DBC. DE over AB equals dF over FC. So we know the ratio between BE over AB, DE over AB, DE, this is D, E over AB, 3 over 4. So dF over FC, it will be 3 over 4. If we have a triangle, the triangle has 3 interior angles, A, B, C. They are the 3 interior angles. What if we are going to bisect the exterior angle? So the triangle, I mean, this is the triangle, ABC. And the 3 interior angles are A, interior angles, and B, interior angles, and C, interior angles. If we are going to divide the exterior angle at the vertex A, so this is called exterior bisector, not interior. This angle is equal to this angle. And this ray is called exterior bisector. Exterior bisector. The exterior bisector divide the base. So firstly, I want to extend this line. So where is the vertex? This is the vertex A. Where is the angle? It's angle A. Okay. And what is the bisector? It's AD. So you should know the angle you should know the bisector, and you should know the triangle. This is the triangle. And the base is BC. This is the base. And we can say that it's side 1. This is side 1. And this is side 2. The exterior bisector divides any face. The exterior bisector from any vertex of a triangle divides the base into 2 parts. Divided the base into 2 parts. The ratio between them is equal to the ratio between the other 2 sides. So let's see how can this bisector divide the base. But in this case, because this exterior bisector, so the exterior bisector divides the base externally. So we can say that DB, the first part, this is part 1, over DC. This is part 2. Once again, how can this bisector divide the base? This bisector divides the base externally. So this is the point which the base meets the bisector. DB, this is part 1, pay attention, please. This is part 1 over DC. This is part 2. So part 1 over part 2 is equal to side 1 over side 2. So DB over DC, DB over DC equals AB over AC. And if you want to divide side 2 over side 1, for example, you are going to write AC over AB. So you should take part 2 because you started with side 2. So you should take DC, this is DC over DB. If you are going to divide part 1 over part 2, so take side 1 over side 2. Why I said part 1 and side 1? Because this point is be the common point between the part 1 and the side 1. And why I called this side 2 and this part 2, because I have seen the common point between them. I hope you get it. And how can we find the length of this exterior bisector, AD? It will be the same, but in the previous one, in interior bisector, we multiply the side 1 times side 2 firstly, minus part 1 times part 2. But in the exterior bisector, you will multiply part 1 times part 2 minus side 1 times side 2. So to find the length of AD, you should find DB times DC minus side 1 AB times AC. Once again, how can we find the length of the exterior bisector? You will multiply part 1 times part 2 minus side 1 times side 2. You will multiply DB times DC minus AB times AC. That's it. If we have a triangle like this one, I'm going to draw an isosceles triangle. This triangle is isosceles triangle. As you see, this side is equal to this side. So this angle will be equal to this angle. If I'm going to draw an angle bisector, I'm going to divide. externally. I want to divide this angle externally. So you will find that the exterior bisector is parallel to the base. Is parallel to the base. How we can deduce that? Let's suppose I'm going to assume that this angle, I'm assuming that is angle 70, for example, and this angle 70. Then the size of this angle will be 40 because the triangle is 180 degrees. The sum of all angles is 180. And you know that the straight angle is 180. So I have 70, 70, 40. Then the sum of these two angles is 140. And I have 40, so divided by 2, it will be 70 and 70. And this is a simple way to deduce that. What do you notice? We observe that this angle, the size of this angle is 70 as the size of this angle. And they are two alternate angles. So because they are equal, so the bisector, the exterior bisector is parallel to the base. Once again, in the isosceles triangle, the exterior bisector from the vertex angle, the exterior bisector from the vertex angle is parallel to the base, is parallel to the base. What is the relation if I have a triangle like this one, and I want to know the relation between the exterior and the interior bisector at the moment? This is the interior bisector of this angle. This angle, the size of this angle is equal to the size of this angle. And I'm going to draw an exterior bisector for this angle. So the size of this angle is equal to the size of this angle. This is interior bisector. And this is exterior bisector. As you know, the four angles, they add up to 180. So the angle labeled cross plus shaded circle equals 180. If we are going to take the two pairs of them, one pair, it will be 90. If you are going to take a pair cross and shaded circle. So what is the relation between interior and exterior bisector? The relation between them, this is the interior bisector, and this is the exterior bisector, as you see. What is the relation between them? They are perpendicular. They are perpendicular. So the relation between interior and exterior bisector, they are perpendicular. So interior is perpendicular to exterior. Interior what? Interior bisector is exterior perpendicular to exterior bisector. Let's try this one. I see that I have a right triangle. This is a right triangle, and this is angle bisector, as you see. This is angle bisector, and this is a triangle. and the length of this side is given as 3, and this side 5, and this is a bisector. And I want to find the length of AB. How can we find the length of AB? And this angle is right. How can we find the length of AB? As you know, because I have an angle bisector, so the ratio between the two parts of the base, 3/4. If you want to find AB over AC, it will be AB over AC equals DB 3/5. But 3/5, it's not the real length of AB, it's not the actual length of AB and AC. So we couldn't say that AB is 3 and AC is 5, but we can say that AB over AC 3/5. So B will be, we can say it's 3x and AC will be 5x. And if you're going to divide 3x over 5x, you will cancel x with x, it will be 3/5. So how can we find the length of AB? The length of AB, it's 3x, and AC, it's 5x. So let's apply Pythagoras. And this side 3, and this side 5, and this side is 8 centimeters. This is the actual length, 8. So it's 5x squared equals 3x squared plus 8 squared. So it will be 25x squared equals 9x squared plus 64. Move 9 to the other side, it will be 25x squared minus 9x squared equals 64. So 25 minus 9, it's 16x squared equals 64. So divided by 16, x squared equals 64 divided by 16 equals 4. Now we can find the length of AB because I managed to get x squared, which is 4. So x equals the square root of 4, x equals 2. So the length of AB, 3x, AB equal the 3x. So AB equals 3 times 2, it will be 6 centimeters. You will take 6 centimeters. Let's take this one. I have a triangle, as you see, and I have an angle bisector. AD is the angle bisector, and the triangle is ACB. This is ACB, and the length of this side is 12, so it's a 12 centimeters, and this is the angle bisector. We should know again what is the angle bisector. This is the angle bisector. This side is the angle bisector. And this is the triangle I'm talking about, which is BCA. And this is the bisector. And what is the base? This is the base. And I have a side 1, 12, and I don't have the length of AC. Let's apply the rule. If you are going to say DC over DB, DC over DB, It will be equal to, this is DC over DB. Part 1 over part 2 is equal to AC over AB. And actually, I don't have the length of DC and I don't have the length of DB, but they are equal. They are equal sides. They are equal sides. This side is equal to this side. So let's put X and X. So DC over DB, it's X over DB, it will be 2X equals AC, I don't know the length of AC, over AB, which is 12. So X over 2X, it will be 1 over 2 equals AC over 12. So AC 12 be 6 centimeters. Let's try this one. If we looked at this triangle is right, as you see, and this is angle bisector. So what is the vertex? This is the vertex, and this is the bisector. This is the bisector. And where is the base? So we should know the triangle firstly. This is the triangle. This triangle is ABC, is the triangle. Where is the base? This side is the base, and this is 8. This is the base. So as you know that the bisector divides the base into 2 parts. The ratio between them equals the ratio between the other 2 sides. So in this case, we can say that 12, this is part 1 over 20, because it's a 12 plus 8, dB over DC equals AB over AC. So dB is 12 over DC, 20, equals AB. I don't know the length of AB, and I don't know the length of AC, but we can find the ratio between them. 12 over 20. If we simplified it, you will get divided by 4, 3 over 5. So AB over AC equal 3 over 5. Okay. How can we find the length of AB? Let's suppose that AB, this is AB, and this is AC. Let's suppose that AB equals 3x and AC equals 5x. So let's apply Pythagoras. AC is squared because this triangle is right, as you see. This is AC, and this is B, 8. So I have AB 3x and AC 5x. Let's apply Pythagoras. So 5x squared equals 3x squared plus 8 squared. As we did in the previous example, 25x squared minus 9x squared equals 64. It will be at the end, you will get x equals 2. So AB equals 3x. So AB will be 6, and AC equals 4x, 5x. So AC equals 10. 5 times 2, 10. After that, I want to find the length of the bisector. How can we find the length of AD? As I said, the bisector equals, because it's exterior bisector. So you'll multiply part 1 times part 2 of the base minus side 1 times side 2. So part 1, 12, square root of 12 times, this is part 1, times 20, minus side 1, it's 6 times 10. That's it. I hope you enjoyed this session. See you the next session. Goodbye.